So, guys, good evening and welcome back. Today, what do we have? We have application of ratios on the questions of time and work. So, as we decided that in this series of videos on ratio and proportion, the motive would be to see how vastly, how aptly, and how efficiently we can apply the concept of ratios across various topics, and it will be only fruitful if we are able to do it. There is no point learning a ratio and proportion as a topic and not able to apply it across the topics, right? So what we're going to do is we're going to take it a step further. Yesterday and day before, yesterday in the last session, we applied the concept of ratios on speed, time, and distance. And today I'm going to show you how, in which sorts of questions you can apply the concept of ratios on questions of time and work. And from there on, you get a good understanding of the application of ratios, right? So that's the case. And that's it. And this is the agenda of the day. So let's see how many of you joined me in the session today. Meanwhile, if you haven't followed us on the various social media, you can do that and you can get started. Okay, hi Rajnikant and hi Anuj. How are you guys doing? Now let's have a look at this question. And with the help of this question, I'm going to explain you the concept and I'm going to tell you how you can approach any question on this format, on this basis, and you can solve it very easily with the help of ratio and proportion, right? Now let us take a case and then we can take it for the high Soumya. So if I say that A does a work in say 10 days and B does the same work in say 15 days and C takes 20 days to complete the same work, right? So what we generally do is you take the LCM as say 60. Now this is the assumed work, right? And when you divide the assumed work by the number of days, this is what we get as the efficiency of each person separately. So this means that if A is putting in 6 units per day, B is putting in 4 units per day, and C is putting in 3 units per day, all of them together would be putting in 13 units per day, right? Now, if I say that A, B, and C, all of them together start the work and they together finish the work or complete the work, end the work. And if they are say given rupees 130 for this entire work, how much would each be getting? Now, in these questions on wages, you have to break down how much money will each and every person get. This will depend on how much of the work has been put in by each and every person. Now, three of them started working together, and three of them would be working till the end of the work, which means that from start to end, if they haven't to worked for X days, A's total output would be 6 into X, B's total output would be 4 into X, and C's total output would be 3 into X days. So ideally what we are doing is we are trying to find a compound ratio of their efficiencies and the time that they worked for. And this, whatever resultant we get over here in these three circles, this is the ratio in which the money will be distributed amongst A, B, and C. So this is what is going to happen. Now, if the format of the question changes, and if I say A does it in say 10 days, B does the same work in 12 days, and say C does it in 20 days, whatever, right? Now, if I say A comes and works for X days, then B comes and works for Y days, and then C comes and works for Z days. Now, the two things have to be considered. First, their efficiencies. Suppose we take an LCM as 60, so 6, 5, and 3, right? So A, B, and C, the efficiencies are in the ratio 6, 5, and 3. This is the ratio of their efficiencies, and the ratio of their times is X ratio Y ratio Z. Now, since each one of them is working for the separate amount of time, now the ratio in which they will get the money is 6x, ratio 5y, ratio 3z. Getting it? Assuming that these are their efficiencies. So over here we are supposed to work on with the compound ratios. So the same concept can now be applied in this question. The question says a work is completed by A, B, and C in 5, 6, and 10 days respectively. If A started working alone and worked for 3 days. After this, B replaces A and works for 2 days. and the remaining work is completed by C alone. Now this is how it is. If C gets rupees 1088 less than A, then what was the total amount received by three of them together? Now you can use this concept very easily, and you can say, okay, fine, A, B and C are taking how many days? Please pay attention, 5 days, 6 days and 10 days. So the LCM of these three values becomes 30, and this is also our assumed work, right? So this is the assumed work that we have at hand. Now what's going to happen is, so 30 divided by 5 will give me A's efficiency, 30 divided by 6 will give me B's efficiency, and 30 divided by 10 would give me C's efficiency. So this is the ratio of their efficiencies. Now what about the time? Talk about the ratio of their times. A works for how many days? 3 days. So A works for 3 days. And then B replaces A and works for how many days? 2 days. And we are not aware of C. No issues. We can leave it like that, and there is no point calculating for C separately. It will get calculated here itself. Now, when we multiply efficiency with the time, what do we get? We get the work, isn't it? So 3 6 are 18, 5 2s are 10. So out of the 30 units being put in, 18 units have been put in by A, 10 units have been put in by B. So 18 and 10 is 28. So automatically remaining 2 units have been put in by C. So if we convert this into a ratio, this becomes 9 ratio 5 ratio 1. So the total money was divided into how many parts? 15 parts, of which A got 9 parts, B got 5 parts, and C received 1 part. And how much did C get less than A? That was equal to 8 parts. Why? Because the total money, A was getting 9 parts and C is getting 1 parts now. So C is basically getting 8 parts less than A. And these 8 parts correspond to 1088 rupees. One part corresponds to one over here to 136, I believe, right? So it is 136. So 8 ones are 8, 2, 8 threes are 24. Yes, 136. So one part is 136. How much would be 15 parts be equal to? As simple as that, 1360 plus half of 1360, 680, I believe, right? Yes, 680. So 0, 4 carried over 1, 0 and 1. So 2040. So rupees 2040 happens to be the correct answer. This way, you'll end up doing least of calculation and the maximum of concept is understood just by applying the very concept of compounding of ratios. I told you in the very beginning that in the direct relationship, work will be equal to efficiency into manpower into time. So we have exploited this relationship between efficiency and time, which is equal to work. And here, therefore, we have used the concept of the compound ratio over here to get onto the work, right? So this is how you can understand questions on such questions on wages. Give me a quick yes in case you understood this so that we can move on to the next question. This was a good question and I just gave you a glimpse of how you can efficiently use ratios. There are other ways of doing the same question also, but since we are trying to apply ratios in various topics, so hence this concept has been used. Give me a quick yes so that we can move forward. And one more information, SSC, CGL mains, SSC, CHSL revised dates have been announced by the government and the SSC. And we will be having our examinations from the month of August and they'll go all the way up to October. Majority of the examinations will happen from August to October, right? So those who are yet to give the CHSL exam and those who are awaiting their SSC, CGL pre-results to come out, so gear up, get ready, and it will be very soon a reality that you'll be giving the examinations, right? So let's move on to the next question. Now this is a slightly easier question. A sum of rupees 2236 is divided amongst A, B, and C such that A receives 25% more than C and C receives 25% less than B. What is the A's share in the amount? Now I'm going to explain you an important concept. Whenever such comparison is happening, don't write A, B, C like this. Now A is compared to whom? C, and C is compared to whom? B. So what you can do is you can keep C in the middle. That makes it more easy for you to comprehend, and it will make it more easy for you to complete the process. So A receives 25% more than C. So 25% is what? 1/4 more than C. So if C gets 4 parts, A would be getting 5 parts. As simple as that, right? And C receives 25% less than B. C receives 25% less than B, which means if B is getting 4 parts, C should be getting 3 parts, right? So the ratio between A and C is 5:4, and between C and B is 3:4. The combined ratio will be 15:12:16. What is A's share in the amount, and what is the total sum? 2,236. So A's share would be equal to 2,236 divided by 15, 12, and 16, 30, 41, 43 into how much A's share? So into 15. Can anybody come up with the answer? How much will be 2,236 upon 43 into 15 be equal? Come on, this will be 5 times. 5 times will be 215 and 80, 52. So we have got 52 into 15. You got 52 into 15, 750 plus 30, 780. Yeah. Option number 3 happens to be the correct answer. Yes, Anuj, your answer is absolutely correct. Let's move on to the next question. Okay, if A is 5/4 as efficient as B, and if B is 4/3 as efficient as C, if three of them working together can do a work in 20 days, then in how many days will A and C together finish the same work? So A, B, and C. So A is related to B and B is related to C, so we'll have B in the middle. A is 5/4 as efficient as B. So B is 5 units, A becomes 4 units. Why? 5/4. Sorry, if B is 4 units, A would become 5 units. My mistake. A is 5/4 as efficient as B, so B has to be 4 units, right? And B is 4/3 as efficient as C. So if C is 3 units, B will be 4/3 as efficient, right? So this is it is. So this is the ratio comes out to be 5:4:3. So the ratio of their efficiencies now is 5:4:3. What next? Abhi, it says that if three of them working together, so if A is putting in 5 units, B is putting in 4 units, C is putting in 3 units, put together they have 12 units altogether in one single day. So 12 units being put in, and they can do the same work in how many days? 20 days. This is 20 days. 20 days, right? So we multiply it by 20. Then in how many days will A and C together? So A and C together will make how many? 8 units. So we divide the total work by the number of units contributed by A and C together. Good evening, Ashu. So you divide it by 2 times over here, 3 times over here. So 30 days is the correct answer, right? Give me a quick yes in case this is understood, and we can move further with the next question. Yes, 30 is absolutely correct. So all you're doing is basically trying and developing a combined ratio between the different types of manpowers, build a ratio of their efficiency, and then you can take the question from there. No problems. Okay, let's move on to the next question. Now, this is a slightly tricky one, and this needs a little bit of calculation. It says 3 men and 4 boys can complete a work in 12 days. 4 men and 3 boys can do the same work in 10 days. Then 2 men and 3 boys can finish the work in the number of days is how much? So let the efficiency of a man be M and let the efficiency of a boy be B. So 3M plus 4B. These are the number of units being put in by 3 men and 4 boys. So the efficiency of a man is M and efficiency of a boy is B. So 3M plus 4B working for how many days? 12 days. So this is manpower into efficiency and this is time. This is what we are doing. So this is the work, right? And the same work is done by 4 men and 3 boys in how many days? 10 days. So this goes away 6 and 5. So we can, from here we can find the ratio of a man and a boy efficiencies over here, right? So we can now tell, okay, fine, 18M plus 24B will be equal to 20M plus 15B, right? So over here, what do we get? We get 9B is equal to 2M. So men over boys will be 9 ratio 2. So the ratio has to be found out with respect to the efficiencies that they have, right? So if a man is putting in 9 units, a boy is putting in how many? 2 units. A man is putting in 9 units, a boy is putting in how many? 2 units. So this is what is required. So once this is with us, for the total work, we've already calculated this or this. So anywhere you can substitute the value. So this will be equal to, we substitute the value here. 4 nines is 36. 3 twos is 6, 36 and 6 is 42. 42 multiplied by 10 is 420. I could have done here also, but the problem is multiplying it by 12 is an issue. So who basically do that way? So it is easier to multiply by 10. So therefore I took this one. So 4m, 4 9 is 36, 3b, 3 2 is 6. So 36 plus 6 is 42. So we have to complete 420 units. How many units? 420 units. And these 420 units have to be completed by how many? 2 men and 3 boys. So 2 men would give me how many? 18 units. 2 men will give me how many? 18 units. And 3 boys will give me how many? 6 units. Each boy is assumed to be giving me how many? 2 units of work. So 2 men and 3 boys will give me how many? 24 units. So 24 into X days. That's it. So that's how you can get it done. So that is easy. And you divide for X, you have to do it what? 420 upon 24. Another way of doing it, that way you can break it down into further values. So 24 is 4 into 6, right? That's 17 and a half days. Yes, you can do that. Okay, this is enough. I was trying to give you some other concept. What I was trying to explain is that rather than calculating this, you can do it factor wise also. You can break down the factors and then you can work upon. But then this is also a proper way of 17 and a half is the correct answer. Yes. Yes, Shashank, yes, Anuj, Rajnikant, all of you given me the right answer. Let's move on to the next question. Let's go quickly. Now, these questions I've taken them deliberately. Why? Because in almost each of the questions, there is a specific pattern. The pattern I'm trying to explain is wherever the question begins or talks about the efficiencies of the people, every such question you can work with the ratios. So you must have observed that the questions that I took in the previous 2 3 questions and this question as well, everywhere somewhere down the line in the question is talking about the efficiencies. The question is talking about the efficiencies and it relates an efficiency of a person to the efficiency of the other person. So wherever in time and work questions, the questions have the mention of the efficiencies, the comparison of efficiencies, you can use the concept of ratios very, very easily. See again, it says A is thrice as good as workman as B. The moment it says A is thrice as good as workman as B, which means that if B puts in 1 unit of the work, A would be putting in 3 units of work. Why? Because A is thrice as good as workman as B and is therefore able to finish the work in 80 days less than B. So if X days is what B takes, A would be taking X minus 80 days, right? This is the number of days we're talking about. Find the time in which they can do the work together. Now, since the work is constant, so the efficiency and time will be inversely proportional. So E1 upon E2 would be equal to T2 upon T1. Just like when we had distance equal, we can now have efficiencies equal. Sorry, work equal. So work is equal, then the efficiencies will be inversely proportional. So the ratio of the efficiencies is 3 ratio 1 and T1 and T2, T1 would be X and T2 would be X minus 80. T1 would be X minus 80, right? So all you can do is you can just work it out over here. The difference is 80 units over here. And over here, the difference is how many? 2 units. So for you to have the same difference both the sides, you can multiply this with 40. So 3 multiplied with 40 gives me 120 units, and 1 multiplied by 40 gives me 40 units. So now the question says find the time in which they can do it working together. So if X is now how many? 120 units, so 120 days, and B took how many? X days to complete the work. So the total work is how much? 1 unit for X days. It is 120 units. And now this has to be worked along and put together. Both of them have to work 3:1, which is 4. So 20 by 4 is how many? 30 days, and 30 days is the correct answer. Right. So the very same concept where we applied in the questions of speed, time, and distance, wherever distance was equal, speed and time were in inverse proportion. Why? Because you remember distance will be equal to speed into time. And it is just the same. Work is equal to efficiency into time. Only the names of the variables have changed. The entire funda, the entire formula, the entire concept remains intact. Right? So nothing to be worried about. If you can apply the concept in speed, time, and distance, you can apply a similar concept over here. All you need to is to understand that over there distance was constant, and over here the work is constant. That's it. That's it. So you can just take it further from that particular topic and use the same logic here also. No different tricks, no different concepts required. Just the understanding of direct and inverse proportion is more than sufficient for you to crack almost 40% of the questions in the examination, right? If you can pay attention, if you can master the concepts and topics of ratio, proportion, and percentage, I can guarantee you, you can easily solve 60 to 70% questions in any exam. Any exam, yes, dude, any exam. Why? Because all the various other topics are related to this only, right? So may what come, don't let these two topics go. Put your best foot forward. Try and solve as many questions as possible from these two very topics. And trust me, you will do wonders in DI, you will do wonders in arithmetic. Take my word for it, right? Let's go for the other question. Now, a builder decided to build a farmhouse in 45 days. He employed 150 men in the beginning and 120 more after 30 days and completed the construction in the stipulated time. If he had not employed the additional men, how many days behind schedule would it have been finished? A very easy question, and I am giving you a home assignment. I'm going to solve this question. I'm going to make you understand the concept behind this question. The home assignment for you is you have to try and utilize the concept of ratios in this question. I would really appreciate if you can apply the concept of ratio in such a question to get a better understanding of the topic, right? As a student, I would always suggest that solving a question is not what is expected. Seeing a question and your thought process going in that direction, in which direction the question will be solved, is the challenge, right? So if you want to really want to crack a good exam, your problem solving abilities have to be developed. You cannot keep on solving the questions and go in the exam and say, okay, fine, I have solved 1,000 questions on profit and loss. I have seen 10-year papers. I have gone through all the faculties, all the YouTube channels, and I'm going to kill it. No. Until and unless you develop a problem solving approach for the questions, it is going to be waste. Trust me. Any number of tricks, any number of short tricks, any number of formula can only come in handy to an extent. But if you develop a problem solving approach, after seeing the problem, you should be having a roadmap as to where and how I should be solving this question. Then the preparation is up to the mark, else not. So don't stop until the time you develop this skill, that after seeing the question, you can understand how to go about it. Rest will be a piece of cake. I'm going to show it to you over here. Now, what is happening over here? The total time given to us is how many? 45 days. He employs how many people? He employs 150 men. And for 150 men, they worked for how many days? 30 days. So a part of work. in first 30 days was done by 150 men. The remaining part was completed in the stipulated time. So how much time we have at hand? Out of the 45 days that the work was supposed to be done, we've already consumed 30 days. So we'll be left with how many days? 15 more days. Somebody's coming up with an answer. Ashu, your answer is incorrect. 15 days are now left. So what this chap does, he realizes that I'm not able to complete the work. So he took 120 more men. So he had to increase his manpower. So 150 were already there. 120 he employed more. So the new manpower was 270. This is the second half of the work which was done. Please try not to pay attention, right? So 150 people worked for first 30 days and the remaining part of the work was done by 270 people working for 15 more days. Now the question says that if if in the second half, the question has nothing to do with the first half. The question is saying if he had not employed the additional men. So this part of the work. So what he is trying to say is that if this part of the work was to be done by only 150 men, not more, how many more days would have taken? So let the same work which was completed by 270 men in 15 days, now the same remaining work has to be done by 150 men in say X days. So this goes away 10 times. So X comes down to 27. So the same work, the second half of the work can now be done by 150 days, but they would have taken 27 days to complete the work. So either you get it done this way or you get it done this way. Hi, Shubham. So what is happening over here? There is a gap of how many days? 12 days over here. 15 days it was taking when 270 people were working, but now only 150 are working. So it will take them 27 days, which means 15 more days to complete the same work. 12 more days to complete the same work. So therefore, the answer is 12 days. Okay, let's take up a couple of more questions and let's do them quickly. So A, now this is an easy one, and this very question should not take more than 10 seconds for you to solve the question. I'm counting till 10. You guys get me the answer, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No answers. This was a very, very easy question. Very easy question. Now A, B, and C. Let's see what the question has to say. Question says A, B, and C can do a work in 4, 6, and 10 days respectively. Now the days are given 4, 6, and 10 days respectively. They finish the work together and earn a total of 320. What is the share of each? 310. What is the share of each? Now the easiest way of doing it is that 4, 6, and 10 given to us. The LCM of these values is 60. Now 60 is what we are assuming to be the total work. So if 60 units have to be done, so 60 by 4 is 15, 60 by 6 is 10, and 60 by 10 is 6. So the ratio in which they will be getting their monies is 15, 10, and 6. 15, 10, and 6. Why? Because till from the very start till the end, everybody would have been working as I've explained you in the beginning of the session. So 15 ratio 10 ratio 6. So 15 ratio 10 ratio 6. You can clearly click the answer like this. So hardly a matter of 5 to 6 seconds that you should be taking. Although you should not be expecting this easy question in the examination, but yes, CHSL you can of course get, and you can get a developed question on this, right? Now, this is an interesting question. So, if you can work on this one, it makes your day. And here is the question. The question says a pipe can empty a tank in 40 minutes. A second pipe with diameter twice as much as that of the first is also attached with the tank to empty it. The two pipes together can empty the tank in how many minutes? Now, please remember this is a 6-second question, not more than this. 1, 2, 3, 4, 5, and 6, and you are done with your answer. So, let's say a pipe A and a pipe B. The question says a pipe can empty a tank in 40 minutes. A second pipe with a diameter twice as much as that of the first. Now, here is the case. Option B, Rajnikant is saying B. Okay, let me see how many of you are giving the answers. Rajnikant is saying option B. Okay. Anybody with an answer? Now, please pay attention. Now, B is the incorrect answer, right? Please pay attention what is happening over here. Now, since the diameter of this pipe is double than the diameter of this, so how much of the water we will be getting from a pipe? So the quantity of the water will be directly proportional to the area of cross section of the pipe, and the area of cross section would be pi r square. So let the radius of the first pipe be r. So this area of cross section of pipe is pi r square. Area of cross section of the second pipe would be pi multiplied by 2r square. Why? Because the diameter is twice. So if the diameter is twice, the radius is also twice. And if the radius is also twice, if the area is say A, this area would be 4A, because the radius, if it doubles, the area will be become 4 times. Why? Because it is dependent on the square of the radius. So if this is putting in 1 unit, this has to put in 4 units, not two. 4 units, not two, 4 units. This is where majority of you make a mistake, right? It has to depend on the area of the cross section. So if A is putting in 1 unit, and for how many? 40 minutes. So 1 into 40 is what we can consider as the total volume of the tank. But if both of them work together, the output will be combined, and 1 plus 4 is 5. So we can fill the same tank at the rate of 5 units. So 40 by 5 will give me 8 minutes, and 8 minutes, option number A happens to be the correct answer. Right, so this is how we can work upon, and this is how we can solve such questions. Not a difficult task, and I hope you understood the concept. And tomorrow we're going to start up with a new topic, and we're going to take up percentage and various other aspects of percentage. Whatever the situation comes, you'll be notified by the night or maybe tomorrow morning. So that will be there, and do share this with your friends. And once again, if you are preparing for the SSC examinations, please pull up your socks, and the dates have been announced, and it is high probability that they will happen on time this time, right? And most probably government might arrange local centers as much as possible, right? So what I see is that if the pre-examination was held in cities A, B, and C, then the mains examinations will eventually be conducted in these cities A, B, and C, not any one of them as it used to happen earlier, right? So that's it from my side, and let's hope you enjoy these sessions. And tomorrow we're gonna come up with a new session. Till then, bye bye. God bless you. Take care.